Radical Dude here, and today we are going to prove the 3 rules of logarithms. Okay, this way you get an idea of where they come from, because most of the time we just use the rules, but we don't understand how they came about. So first of all, the basics are first writing an exponential equation. Let me let b to the x equal a, b to the y equal b. And we're going to keep referring back to this. Alright, how do I rewrite this? Well, I want to rewrite this using logarithms. So it's very simple. This is how I do it. This is the base. So I start with my log. This is the base here. Now remember, if you get confused, Napier wanted the exponent as your answer. So your answer over here is x. What letter am I left with? A. There it is. If you don't like that, you can just say very simply, y, the exponent, is my answer. So I can start with the answer. Now I put the log. You know it's to the base, and then you have the b. Whatever way you do it, you have to be able to go back and forth. Okay? Now, the first rule is the product rule. And the product rule says, if I take the log of base b of ab, I get the log in base b of a and the log in base b of b. Now, let's see why that is. Well, let's start with ab. AB. Well, a times b is equal to, if we go back, a times b is equal to b to the x times b to the y. So that's b to the x times b to the y. And what you know, when you multiply the same base, you add the exponents. See? It's based on these exponents. Now, we want the log of this. So I take the log of AB, which is the same thing as the log in base b of b to the x plus y. Now, when we rewrite this, we're saying b to the what exponent is b to the x plus y. Well, these b's are the same. So what's missing is the exponent, x plus y. Now, if log in the base b of ab equals x plus y, then log in the base b of ab equals, what was x and what was y? X is log in the base b of a, and y is log in the base b of b. So therefore, we have log in the base b of a plus log in the base b of b. We just proved product rule. And with the same idea, same steps, you can prove quotient rule. Quotient rule. Quotient is the divide. So that says basically that if I have the quotient of these two, then that equals log base b of a minus log base b of b. Now let's see why that is. Well, we start with what is a over b? Well, when we went back and looked at it, a, right? A was b to the x, b was b to the y. So it's b to the x over b to the y, which you know from quotients of the same base, you subtract the exponents. Right? Now we take the log of it. The log of a over b equals the log in base b of b to the x minus y. Same reasoning. B to the what is b to the x minus y? It's x minus y. And then what is x minus y? Well, we went back, same principle. X is log a in base b, and y is log b in base b. So it's log a in base b minus log b in base b. We just proved the quotient rule. Now the last one is the powers rule. The powers rule. And what the powers rule says is log in base b of a to the c equals c log base b of a. Now, how do we get that? Well, we're going to let a, let's go back. What do we let a equal? B to the x. So, a is b to the x. But we want a to the c power. So I raise this to a c, then I have to raise this to a c. And that equals b to the x c. Right? Now we take the log. Log base b of a to the c is the same thing as log in base b of b to the xc. So you're taking the log of both sides. Well, b to the what power is b to the xc? It's xc. And you can make this commutative. This is commutative multiplication, so you switch it, you got cx. And now I just substitute. So I have log of base b of a to the c equals cx. We'll keep the c, and what do we say the x was? Well, the x was log of b, a. And there you go. We just proved the powers rule. So, that was the way to prove the 3 rules of logarithms that you need for high school. And this has been Radical Dude, and I hope you learned something.